Hello all, I am Dr. Rizvi and this is part 5 of our video on shear force and bending moment. And in this video we will solve the numerical on cantilever beam. Here in this figure you can see a cantilever beam having point A fixed and the point E is free. It is carrying a load of 1 kilonewton at point B, a UDL between C and D of 2 kilonewton per meter and a point load of 1 kilonewton. So let us start with the numerical. To solve the numerical initially we will first draw the free body diagram and we'll depict all the forces acting on the beam. So at point A there will be three reactions RAX, RAY and MA. This is point A. At point B it is facing a 1 kilonewton. It is being loaded 1 kilonewton here. Between C and D, it is carrying a UDL of 2 kilonewton that will act at the center and it will be 2 into 2 equals to 4 kilonewton. The total load will be 4 kilonewton and it will act at the center of C and D, 1 meter from C and 1 meter from D. And finally, a 1 kilonewton load is acting at point E. After solving this, we will solve the general conditions of equilibrium and we will find out the reactions. The general condition of equilibrium are sigma fx equals to 0, that is all the forces that are acting along x axis are 0. From here we will get Rax equals to 0. The next condition is sigma fy equals to 0. From here we will see that upward direction forces are positive and downward direction forces are negative. From here we will get the value of Ray equals to 6 kilonewton. And the third general condition of equilibrium is sigma ma equals to 0. Sum of all the moments acting on the beam are 0. And we can see that at point A there is a moment ma that is lifting the beam upward, and rest of the forces, that is 1 kilonewton, this 1 kilonewton, this 4 kilonewton and 1 kilonewton, they are making downward movement to the beam, so they will be treated as negative. So minus 1 into perpendicular distance from point A is 1, minus 4 into perpendicular distance is 3 and minus 1 into perpendicular distance is 5. From here we can find out the value of Ma and it is coming 18 kilonewton meter. So we have found out the value of all the three reactions that are acting at the fixed end of the beam. Now we will start the calculation for shear force. We will start it from free end, that is point E. We will cut a section just near to point E like this, and we can see that from the sign convention of shear force, when we cut the section, the upward direction forces toward the left are treated as positive and downward towards the right are treated as positive, while when we cut the section the forces that are moving like this are considered as negative. So here you can see that 1 kilonewton is moving in the beam in clockwise direction, and so it will be positive and it will be 1 kilonewton. Shear force at point D will be also 1 kilonewton since no force is acting at point D. When we cut the section at point C, we can see that there are two forces that are moving downwards toward the right of the section. So both are positive. So total force will be 5 kilonewton. Now shear force at point B. We can see that one more force is there. So there are three forces, 1 plus 4 plus 1, total force 6 kilonewton. And finally, when we move to point A, there is a force that is in upward direction towards the right of the section, so it will be treated as negative, and the rest of the three forces, that is 1 kilonewton, 4 kilonewton and 1 kilonewton, will be positive. So shear force at point A will be equals to 1 plus 4 plus 1 minus 6, and it will be 0 Newton. And this must come 0 because when we are solving the shear force diagram and we do the calculation for shear force, this the last point shear force must be 0. It will prove that our calculations are correct. We have done the calculation for shear force over the beam. Now we will move on to the bending moment calculation. For bending moment calculation, we can see that at point E, since it is a free end, so bending moment at point E will be equals to 0 because it is free end. Bending moment at point D. Bending moment at point D will be equals to, since there is only one force of 1 kilonewton moving downward from point D, so it will be 1 into 1 and that too of minus sign, so it will be minus 1 kilonewton meter. Bending moment at point C. Since when we cut the section at point C, there are two forces, 4 kilonewton and 1 kilonewton, and both are in downward direction, so both are negative, and so the forces moment will be minus 1 into perpendicular distance is 3 and minus 4 into perpendicular distance is 1, so it is minus 7 kilonewton meter. Bending moment at point B. There are only two forces and 1 kilonewton is acting on that point, so it will not be considered. So minus 1 into 4 and minus 4 into 2, it is minus 12 kilonewton meter. And finally, bending moment at point A. So bending moment at point A, now 1 kilonewton force, this one will also be considered, and so it will be minus 1 into 5 minus 4 into 3 and minus 1 into 1 equals to minus 18 kilonewton meter. Like this we will solve our bending moment calculation, and we have got the bending moment at all the points of the beam. Now we will plot the shear force and bending moment diagram. We will draw the shear force and bending moment diagram. First of all, we will draw the shear force diagram as per the calculations that we have got. We will draw a straight line below this diagram and we will mark our shear force. At point E, it is 1 kilonewton. At point D, it is also 1 kilonewton. At point C, it is 5 kilonewton. At point C, it is 5 kilonewton, and at point B, it is 6 kilonewton. And finally, it is coming to 0 at point A. Here at point E, D, C, and B. Now we'll join the lines like this. Between C and D, since it is a UDL, so we'll draw an inclined line joining C and D. Here it will be straight since no load is acting between B and C. This is how we will draw our shear force diagram. This is an inclined line. This is 1 kilonewton. At point C it is 5 kilonewton. Here it is 6 kilonewton. Finally at point A it is 0. So this is shear force diagram for our cantilever beam. Now we will draw the bending moment diagram. For bending moment diagram, at point E, bending moment is 0. At point D, bending moment is minus 1. At point C, bending moment is minus 7. At point B, bending moment is minus 12 kilonewton meter. And finally, it is minus 18 kilonewton meter at point A. So now we'll join the points. This will be inclined line. This will be a second degree parabola. Inclined line, since no load is acting between these points. Inclined line. This is our bending moment diagram for the question. The lines are not straight for this because I am drawing it on digitizing pad. When you will draw on it on copy, it will be straight. Bending moment diagram. This is parabola, and all the rest of the lines are inclined lines. So this is the solution for the given cantilever beam. Thank you.